Okay, so hi everyone. Welcome to this session. Marco before told that coffee and beer were available, and now you get me, so I know if you are pissed off, I can get that. In this session, I will talk about recommendation engine and how we, well, get started with that. In the beginning, a client of ours, which have an commerce web shop, which sell books, both digital and paper books, in particular love books, you know. It may sounds funny, but they do good money. And one day they come to us and they ask them, okay, we just want to do, we want to improve our business and we want to do what Amazon does. Okay, so I thought, okay, so you want to sell like 1 million books in a day. That will work. It will improve your business. No, they meant something different. They said, okay, we have a lot of titles, 1,000 and 1,000, and we think that might be, it's a good idea to try to suggest to our user, to our clients, actually, well, books that they might like. Okay, can you do that? And we say, oh, yes, sure. Actually, we haven't the slightest idea on how to do that. So we start a study, and well, this talk basically is about what we discovered and what approach we took. You can think, at least we thought in the beginning, that recommendation engine were a sort of search engines, right? Because they help you find something you might need. Like it's a search. Make sense? Actually, no. Search engines works in a different way. Okay, you have a document base which is pretty static, and you issue different queries. Okay, think about Google. Okay, here we are asking several different things. Recommender systems work in a different way. Here is a snippet of my Netflix account. I do like to watch TV series. The latest one I watched was 30 Reasons Why. So Netflix suggests me, okay, so you watched 30 Reasons Why, you might like Prison Break. How many of you have ever seen Prison Break? One. I know a few. Okay, good. Sense8. Never saw that. Okay. And then Netflix suggests me try to watch 50 Shades of Grey. Really? Okay. Well, the idea is we have a growing document base, more movies, more titles, and well, we have no query here, okay? We just want to find something that we are maybe interested in. Okay, there are several approaches on how to do that. I won't go deep down in the detail of every algorithm, but still I want to give you a quick overview on how to do that and what are the approaches available. First one, non-personalized recommendation. Well, as the name suggests, this means that every user got exactly the same recommendation. They are non-personalized, okay? Think about like bestseller lists or top 10 lists, okay? Basically, we have this kind of stuff in every e-commerce, okay? Every user got the same, pretty straightforward. Think about TripAdvisor, okay? The user rates the venues, and then we got a list that is the same for everyone. Okay, non-personalized recommendation. Second approach, content-based recommendation systems. These kind of systems are more complicated because the idea behind that is, okay, for a particular domain, let's say the movies domain, okay, we build a user model which contains attribute. In the movie domains, it could be something like the actors, the directors, the type of the movie, if it's an action movie or whatever. Every of these attributes has a particular weight, and we use this model to find something we might like. This kind of recommender systems can be implemented with search engines. Okay, how many of you use Elasticsearch? A few. Solar. Okay. Okay, in Elasticsearch, for instance, you can customize the score function you use to, well, retrieve documents for a given query. And this fits well with this approach. Latest approach, which is the one I want to focus on in this presentation, collaborative filtering algorithm. Basically, they don't need to analyze content, as in content-based recommendation, because if you're going to use a search engine, you need to index the content. And, well, they also allows you to capture, well, there is this things called serendipity, finding something you like in an unexpected way. With content-based recommendation, it is not possible. With collaborative filtering, it is. Okay. We have two different algorithms here, user-user recommendation and item-item recommendation. In the user-user recommendation, the idea is, okay, for a given domain, let's say songs or movies or books, there will be some user that will share my tastes, okay? And I want to use their opinion and combine them to have a recommendation for me, okay? So if I and you rated a lot of movies in the same way, and you saw a new movie and you liked it, well, I might like it. So basically, we can see this problem as a big matrix. Here we have in the column the movies, in the rows the users. User-user algorithm try to find similar user, calculate a similarity score, okay? In this example, Joe and Tom are similar. Well, maybe yes, because they rated this 2 and 3 on a scale to 1 to 5, 3 and 3, and okay, so they are pretty similar. Also, Tom rated this item, and Joe didn't. So is Joe going to like this movie based on this similarity? Well, probably not. That's the core, the idea behind this kind of algorithm. Make sense? Okay, more or less. Feel free to ask questions if I'm not clear enough. Yeah. Yeah, okay. Well, the idea, as I hope to show after a few slides, is you can just track several action the user performs on your system, which is not only like or dislike, which is not only starring, and all these action contributes in creating a recommendation for you. So in the end, it matters, but it's not that important as you may think. Okay, another approach, item-item recommendations. Here we're trying to do something slightly different. The idea is, in the previous example, we reasoned on the rows, okay? We're trying to find similar users. Here, it's the opposite. We are reasoning on the columns, okay? So I want to find items which are similar to a given one. In this way, I can answer the question, given a particular book or movie, which are similar books or movies, and they can recommend them to the user. What are problems or limitation of this approach? Well, first one, sparsity. If you have a lot of data, a lot of user, a lot of objects, probably users are going to rate only very few of them. Okay, think Amazon. They have millions of items, and maybe the user is going to rate, I don't know, 10, 20 of them. Okay, so we have this really, really big matrix, which is basically really, really low populated. And calculating recommendation in this scenario can become difficult. User cold start problem. When a new user enters in the system and start using it, at the very beginning, we don't have enough information to, well, provide meaningful recommendation for him because it hasn't rated or, well, used the system enough. The same goes for item cold start problem. When we have a new item, again, we have no information about it. So in the beginning, it will be difficult to recommend it. And we need, again, to wait a bit. With minimum ratings, computation becomes low. Okay, so what about our domain? As I said before, we want to create recommendation for an online bookshop, and we were interested basically in two kinds of recommendation. The first one, who bought this also bought. So it's like a similarity recommendation, and you might like. Okay, based on user activities. At this point, we needed to choose the tool we had to use to implement that. And when we started the project, there weren't a lot of alternatives, actually. And we found this one, which is Prediction.io. It's an Apache project based on, think like an Elasticsearch, but focused on recommendation, okay? So the idea behind that is the same. The architecture is a bit different. You have two main parts, the event server, which collects information coming from several applications you might have. Think about a mobile app, a website, an email campaign, whatever. These data are collected and passed to the second part of the systems, which are the engines. Engines are in charge of computing, calculating the recommendation for every user and answer when they are queried. Both of them are accessible via a REST interface. So it's pretty simple to communicate with both of them. If you want to, well, give it a try, the easiest way to get started probably is use like an Amazon AMI, which is a pre-baked image, and it contains everything you need to get started. You can also install it via source code, but it's a bit more longer, okay? Also, you can choose two kinds of storages. The default one is based on HBase, which is a distributed database, and Elasticsearch. While if you have less data, okay, and a smaller project, you can go with MySQL or Postgres or whatever. And again, it's more simpler to install and configure. Okay, let's spend a few words on the event server. As I said before, it's the part of the systems that collects user action. Before I talked about ratings, okay? But ratings are only one part of the one possible action user performs on your system, okay? You can also keep track of other action. Let's say the user liked someone, some items, or the user bought some items, or the user put an item in its cart or in its wish list, okay? All these are examples of user action we can use to recommend, to calculate recommendation for a given user. And in general, you are going to save 3 kinds of data in the given server: users, which are needed to perform correlation between user and items, obviously, and events. Events are a triple user action item. So these 3 are examples of possible event you might want to track in your application. User 1 purchased product X. User 2 viewed product epsilon, and so on and so forth. Make sense? Okay. How can we save all these events to the event server? The first thing we need to do is to create a new application. In Prediction.io, an application is basically a container for your data. Okay, so with one running instance of prediction, you can host several applications, and data won't interfere. So you can provide several recommendations from several different applications, totally uncorrelated. Here we are creating a new app called My App 1, very interesting name. After that, you got this lengthy token. You can use as an access token, and you need to pass it on every API call in order to get authenticated. After that, we are done basically for this part. We can start the server with this command, and the server will run on the port 7070 by default. And basically we're done. You can try to see if everything is fine, curling it on port 77. If you got this JSON back alive and kicking, fine. We can start to send events from our applications. Also, you can try to query the events available, again passing the access key, which can be useful because if you think about it, well, we're going to track events that make sense from business point of view, usually. Okay, we're going to track rating, likes, purchases, and so on and so forth. So, well, you can use this store also for other kind of analysis, business related. Here we are trying to fetch all the events, which is in general not a good idea because usually there are a lot. So you can also pass different parameters like a date range and stuff like that. Yeah, events modeling. What can or should we model? Well, these are some few examples: rate, event, like, buy, view. And depending on the algorithm, I'm going to show it in a brief moment, you can map more or less event. And the algorithm will take care of that, of them, and well, use it for calculating recommendation. Okay, in this snippet is the snippet of code, which is not really readable. Okay, you can see how to use the SDK, which actually is just a thin layer, a thin wrapper for pull request. Okay, so you can do the same without using anything, but it's a little bit easier. Here we are instantiating an event client, passing the access key, the one we got before from the application, and then here we are creating an event, passing an array. Okay, the array should contain the entity type, which is user. Okay, thank you. The entity ID, the item ID, and the target entity type. Here we are 3 examples. They are not really readable, but the idea is here we are mapping a rate event. So here the user with ID 1 rated the item with ID 1 with a rating of 4. So in this way you can map basically all the events in your application. Here is an example of an event involving only one entity, in this case the user, but you get the idea. So the components are items, users, and the action. Okay, this is the SDK, which is really, really small. Set, unset user or delete user, the same for event, set, unset, a delete item, for item, sorry. And here we can record user action on item, which just underneath use create event. Again, pretty straightforward. Engines. Engines are the part of prediction that compute the recommendations. You can choose between a lot of predefined template, which implements several algorithms. For instance, this is one of the most used, universal recommender. Maybe it's not really universal, but okay. It does a lot, actually. And you can install it just with this command. It will download this template in this directory. And to get up and running, you need to modify an engine.json file inside this directory, which will be generated for you. Depending on the template, you can tweak more or less parameter. At the very least, you need to change two things. First one, the application name, my app one, the one we created at the beginning, and you need to specify which events you want to, well, be taken in account for that particular engine. After that, you need to build the engine, you can train it, and you deploy it. After deploying it, a service listening on a given port will be created. And basically, you're done. Getting recommendation is pretty simple. You need to use this engine client, specifying the engine IP and port. You can ask two kinds of questions here. The first one, with send query, we are saying, okay, give me 4 recommendations for the user with ID 1, and which is a way of getting recommendation. The other one is, give me 4 similar items to item 1 with ID 1. The code is exactly the same, just this is the different part. In both cases, you get a list of scores and item ID. Okay, item 22, 62, 75, 68. Okay, how do we implemented it in our application? The bookshop, remember? Okay, two kinds of suggestion. We both these also both, so a recommendation, and you may like similarities. We decided to track these events, the view event, the like, which represent add to basket and add to wish list action, a conversion, which represent the buy action. All these events are recorded in batch, which means that they are put in a queue, and then the queue is processed and sent to prediction. Okay. Well, when we started the project, the universal recommender were available, so we needed to complicate things a bit. We needed to create 4 engines, 2 for books and 2 for ebooks. Now probably is not needed, because you can also use additional parameters when registering events, and you can just filter recommendation by type. For instance, you can say, okay, so give me recommendation but only ebooks, or give me recommendation but only books. So it's slightly less complicated now. Also, we retrain the engines every night with the new data. Okay, so every retrain, the recommendation will be updated, keeping count the latest action the user performed in the system. We also created a small, relatively small API to ease recording of the different kind of events. Again, pretty straightforward. Okay, and these are the 2 API for getting similarities and recommendation. Okay, where we shown the recommendation to the user, we started putting it in the website, in particular in every detail page at the bottom and in the sidebars, all over the website actually. We also experienced the user called start item called start problem. So the idea is we try to fetch recommendation for a given user, for a given logged user actually. If we get enough, we show them. Otherwise, we just switch to no personalized recommendation. So we show otherwise like a bestseller list or whatever. Like in this example, okay? Here is just a non-personalized recommendation. Okay, the end, almost. We went online, we let the system run for a bit, and things went pretty fine. The client was pretty satisfied, and we also started to use recommendation for sending a personalized email to every user once per month. And that's it. I want to spend really few words on some alternative approaches, because if I'm asked to do that now, today, probably I will take a different way. First of all, if you're interested in this, this is a really, really good and complete list of recommender system, libraries, servers, software as a service system for recommendation. And I suggest you to take a look at that. Another approach is, well, using a suggestion as a service like Suggest Grid. The idea behind that and the principle are exactly the same of Prediction.io, okay? So you send some kind of events to the system and you ask for recommendation similarity. Basically, you're done, okay? Without the hassle of installing Elasticsearch, HBase, and so your ops guys won't be angry because you keep asking them to install new stuff. If you don't have a lot of data, you can try to roll your own. This is a really, really small project. And when I say small, I mean really small. 2 files, one for the event store and the other for the algorithm. And okay, you might think, okay, it's 2 files with 1 million line each. No, they're really, really short files. And also, if you want to understand how things work underneath, this is a good starting point. The code is really, really clear. It's JavaScript, so it's not PHP, but who cares? Latest approach, graph databases. The idea here is you can model your domain with nodes that represent like user or objects, items, and nodes are connected by edges. Every edge has a particular meaning. So here I'm saying this user is friend of this user, okay? And by creating this graph and navigating this graph, you can fetch recommendation for your user. Okay, again, I get that it's a really, really quick way to introduce that, but I hope that you get a general idea of the available solution, and well, that's it. I am Michele Orselli, I work for Ideato, I'm the CTO. These are my references, my email, my strange Twitter name. And well, if you have questions here, please rate my talk. Thank you.